Did you know that our universe is an immense, boundless expanse filled with billions upon billions of stars, each with its own story to tell? Every star is a sun in its own right, potentially orbited by planets that remain unseen to the naked eye. As we gaze up at the night sky, we can't help but wonder what mysteries lie hidden amongst those twinkling lights. Could there be worlds out there unlike anything we've ever imagined, with landscapes and environments beyond our wildest dreams? Join me now as we venture beyond our familiar Earth, embarking on a journey to explore the universe's most bizarre and fascinating phenomena. Our cosmic quest is to uncover the secrets of worlds shaped by forces that defy our understanding. Imagine a planet where oceans float in the sky, or where days and nights last for years, creating a surreal and otherworldly environment. This is no longer the stuff of science fiction, but a glimpse into the very real possibilities revealed by our latest scientific discoveries. These are the stories of alien planets, of life pushed to its absolute limits, and the awe-inspiring power of the cosmos. Fasten your seatbelts, it's going to be a fascinating ride through the wonders of the universe. Picture this, a planet shrouded in perpetual twilight. The sky is a deep, dusky hue, casting an ethereal glow over the landscape. Shadows stretch long and mysterious, creating an otherworldly ambience that feels both eerie and enchanting. The air is thick with a sense of mystery, as if the planet itself holds secrets waiting to be uncovered. Above you, a shimmering expanse of water, an ocean suspended in the sky. Imagine looking up and seeing waves gently rolling, reflecting the dim light in a mesmerizing dance. This ocean isn't bound by the ground, but floats majestically above, defying our earthly expectations. The sight is both surreal and breathtaking, a testament to the wonders of the universe. This, my friends, is no fantasy. Scientists believe such worlds with inverted oceans could actually exist. The concept challenges our understanding of planetary science and opens up a realm of possibilities for what life could be like on these distant worlds. Imagine the scientific breakthroughs that could arise from studying such an extraordinary environment. But how could an ocean possibly defy gravity? The answer lies in the planet's atmospheric pressure. Imagine an atmosphere so thick, so dense, that it creates a force strong enough to lift and hold an entire ocean above the surface. This dense atmosphere would be rich in gases, creating a unique and dynamic weather system, unlike anything on Earth. Imagine an atmosphere so dense, so heavy, that it pushes the ocean upwards, suspending trillions of gallons of water high above the planet's surface. This immense pressure creates a unique environment where water can exist in a state of suspension, forming a floating sea. The sheer scale of this phenomenon is mind-boggling, a true marvel of nature. Life on such a world would be unlike anything we know. The creatures inhabiting this floating ocean would have to adapt to the unique conditions, evolving in ways we can only begin to imagine. These adaptations might include specialized buoyancy mechanisms, unique respiratory systems, and extraordinary sensory organs to navigate their aerial habitat. Creatures, perhaps resembling jellyfish or squid, might drift effortlessly in the sky-borne sea. These beings could have developed specialized adaptations to navigate the suspended waters, using buoyancy and gentle propulsion to move gracefully through their aerial habitat. Their movements would be a mesmerizing ballet, a dance of survival in a world turned upside down. Below, on the dimly lit surface, plant life would have to adapt to survive with minimal sunlight, perhaps developing bioluminescent properties to create their own light. These plants might glow softly, illuminating the landscape with a gentle, otherworldly radiance, creating a surreal and beautiful environment. The interplay of light and shadow would create a constantly shifting tapestry of colors and shapes. Could we, as humans, ever survive on a world with an inverted ocean? The challenges would be immense. The crushing atmospheric pressure would require us to develop advanced technology and specialized suits to protect ourselves. These suits would need to be incredibly durable, capable of withstanding the intense pressure while allowing for mobility and functionality. We would need pressurized suits to withstand the crushing atmosphere and special equipment to access the water above. Our technology would have to be incredibly resilient and adaptable to cope with the extreme conditions of such a planet. Innovations in materials science, engineering, and life support systems would be essential for survival. Yet the thought of exploring such a world, of swimming in an ocean suspended in the sky, is a tantalizing prospect indeed. Imagine the thrill of diving into these floating waters, surrounded by alien life forms and illuminated by the bioluminescent glow of the plants below. It would be an adventure unlike any other, a journey into the unknown that could redefine our understanding of life and the universe. The experience would be both exhilarating and humbling, a reminder of the boundless wonders that await us in the cosmos. In our solar system, the Earth spins gracefully on its axis, gifting us the familiar cycle of day and night. This rotation, taking approximately 24 hours, creates the rhythm of life as we know it, with the sun rising and setting in a predictable pattern. But imagine a world where the sun remains fixed in the sky, casting an eternal day upon one hemisphere and an endless night upon the other. Such a scenario might seem like science fiction, but it is a reality for many planets beyond our solar system. This phenomenon, known as tidal locking, is more common than you might think. In fact, many of the exoplanets discovered in the habitable zones of their stars are tidally locked, presenting unique challenges and opportunities for any potential life forms. Tidally locked planets orbit close to their stars, their rotations synchronized with their orbital period. This means that one side of the planet perpetually faces the star, basking in continuous daylight, while the other side remains shrouded in eternal darkness. This means that one side of the planet perpetually faces the star, while the other remains shrouded in darkness. The stark contrast between the two hemispheres creates extreme environmental conditions that would challenge any form of life. Life on such a world would be a study in contrast. The sunlit side would be a harsh, scorching desert, while the dark side would be a frozen, icy wasteland. The narrow band of twilight between these two extremes could be the only habitable zone. On the sunlit side, plants might develop metallic sheens to reflect the intense radiation, while cold-blooded creatures bask in the perpetual warmth. These adaptations would be crucial for survival in such an unforgiving environment. Conversely, the dark side could be home to creatures that navigate and hunt using echolocation, their bodies adapted to the frigid temperatures. Bioluminescence might be a common trait, providing light in the perpetual darkness. The boundary between day and night, a narrow band of perpetual twilight, could be a zone of incredible biodiversity. Here, life forms from both extremes might meet and interact, creating a unique and dynamic ecosystem. Here, life adapted to both extremes might converge, creating a truly alien ecosystem. This twilight zone could be a place of constant change and adaptation, where species evolve rapidly to survive the fluctuating conditions. Could human colonists ever bridge the divide between these two drastically different worlds? The challenges would be immense, but so would the rewards. Advanced technology and innovative solutions would be necessary to create habitable environments on both sides of the planet. It's a question that sparks the imagination. The idea of humans adapting to such extreme conditions pushes the boundaries of what we consider possible. As we continue to explore the cosmos, the potential for discovering and colonizing tidally locked planets remains an exciting frontier. Supernovae, the explosive deaths of massive stars, are some of the most powerful events in the universe. These cosmic cataclysms mark the end of a star's life cycle, releasing energy that can outshine entire galaxies for a brief moment. They release unimaginable amounts of energy, briefly outshining entire galaxies. The sheer magnitude of these explosions is almost beyond comprehension, with shock waves that can travel across the cosmos, affecting everything in their path. But what if life existed on a planet orbiting a star on the verge of going supernova? Imagine a world where the inhabitants are aware of their star's impending doom, living under the constant threat of annihilation. Could life not only survive but thrive on the edge of such a cataclysmic event? The idea seems far-fetched, yet the universe is full of surprises. Life has a way of adapting to the most extreme conditions. It seems improbable, even impossible. The intense radiation and energy from a dying star would create a hostile environment, seemingly uninhabitable by any form of life as we know it. Yet, life is remarkably resilient. On Earth, we find organisms thriving in the most extreme environments, from the deepest ocean trenches to the hottest volcanic vents. These extremophiles show us that life can adapt to conditions that would be lethal to most known species. Imagine creatures that have evolved to harness the intense energy of their dying star. These hypothetical beings might have developed unique adaptations, allowing them to not only survive, but flourish in such an environment. Perhaps they have developed bioluminescence on a grand scale, their bodies glowing with the captured energy of stellar winds. This bioluminescence could serve multiple purposes, from communication to attracting mates, or even as a defense mechanism against predators. The planet's atmosphere itself might be charged with energy, creating spectacular auroras that illuminate the alien landscape. These natural light shows could be a common sight, painting the skies with vibrant colors and patterns. Life on this world would be a constant race against time, a delicate balance between harnessing the star's energy and succumbing to its inevitable fury. The inhabitants would need to be incredibly resourceful, finding ways to shield themselves from the most intense bursts of radiation while still utilizing the energy for their survival. It's a testament to the sheer tenacity of life, a reminder that even in the face of cosmic destruction, life finds a way. The resilience and adaptability of life forms, whether on Earth or in the far reaches of the universe, continue to inspire and amaze us. The story of life on the edge of a supernova is a powerful illustration of the enduring spirit of survival against all odds.